Hi, everyone, and thanks for spending your Monday morning with us. I'm Jason Hunter, Principal Solution Architect with DynamoDB, and I'm here with Sean.
Hi, everyone. My name is Sean Shriver. I'm a DynamoDB Solutions Architect. I've been with AWS for 11 and a half years.
And that's what we look like. 11 and a half years.
Yeah, I started in AWS Premium Support, and then about 10 years ago, or actually over 10 years ago, I became a DynamoDB SME, which is an accreditation side of AWS. And then I've been a DynamoDB Solutions Architect for 8.5. So the longest tenure in DynamoDB SA everywhere, worldwide.
We go to him when we're stuck.
Yeah.
The buck stops with Sean, basically. We're here today to talk about core data modeling concepts with DynamoDB. And to level set, I'd kind of like to know how many of you have done data modeling with DynamoDB already? Wow.
That's amazing.
It's about half, right? So hopefully we'll still give you some good stuff. We're going to show you some of the more advanced techniques to help you scale when you really want to handle, many thousands of requests per second. We're going to start with an analogy. And the hardest part of a talk like this is how do you get set up where someone who's new to Dynamo is going to not get lost as we get deep, while someone who's familiar with Dynamo isn't going to think the first 15 minutes are boring. So here's my attempt. I'm going to try to explain how DynamoDB data modeling works like phone books, okay? A library full of phone books.
I remember phone books. Can you keep my mic on? Thanks. I remember phone books.
You remember? So here's the next question. How many people remember what phone books are? Yes.
Awesome.
Represent. Back in the day, before your phone had every number you'd need to contact, you'd pick up a book, and it would have the city name on the side, and inside would be sorted by last name, typically, the people that you might want to call. And so I'd go to San Jose, and I'd find Jason, but I wouldn't find Jason. I'd find Hunter, his last name, and then there's the phone number, right? So it would kind of look like this. And I should credit, by the way, Alex Debris, who, maybe you're out there, Alex, does a lot with Dynamo, and he said that it reminded him of a phone book. And I wanted to take that analogy all the way. Am I losing sound?
Yeah, it's dropping out.
I'm looking at you, man. Am I good? All right. So in the phone book, there were the white pages up in front, and that was the outside of the book was the city. So here we have Las Vegas. We're calling that the partition key in DynamoDB, for those of you who've done DynamoDB. And then we have a sort key, which is going to be the name. It can be sorted by whatever, but typically phone books did it by last name. So we see Hunter, Jason, JW Marriott, Trevor, Sean, and the Venetian. And after that's the stuff you want, the payload, the phone number, the zip code, the entity type, whatever it is. So if you remember, flipping it open. So if you have something like this, and this is a lot like how Dynamo stores data, because it's very fast to find things, but what can you do and what can't you do? If you know the city, if you know the last name and the first name, you can find that person really quickly. You crack it open, you can find it right there. It's kind of like a binary search very fast. I can find all Hunters, all Shrivers. I could find all last name starts with H or HU. Could I find all Jasons? No, right? Because it's not sorted by that. Well, I can, but I'd have to look through the whole book. If you think about the physical book, you have to look through the whole thing. Could I find by zip code? No. Could I find whose phone number this is? No. There's things you can do, things you can't do with this partition key, sort key combination. Now, great. Real white pages had this concern, so they added yellow pages. You remember the back of the book was yellow. That was the commercial index, and instead of by name, it would be by type, like a plumber, handyman, things like that. And so in the same book, the same partition key organization of Vegas here, you'd have an entity type of a casino, and you'd have all the casinos, or hotel, and you'd have all the hotels. And then from there you could see like, oh, I like that casino, maybe I'll book my room there. And it's called a local secondary index because it's in the same book, basically. And that's a lot how DynamoDB local secondary indexes work. It's the same partition key, but a different sort key, but kept together. There it is. What queries can we do, can't we do? Kind of covered it. And then there's another thing in Dynamo that has an analogy to phone books, which is a global secondary index. Under this, instead of the spine being the city, and you look up by, oh, well, I know what city the person's in, maybe you know something else. Maybe you know the zip code. And so here we have, for this one zip code, not all the entries are in it, but I have a GSI partition key by zip code, and a GSI sort key by name in this case. So now what can I do, what can't I do? if I know the zip code of the person, but not the city, because sometimes zips and cities don't match exactly. I can find you knowing your zip code. And it's in a different book, though, right? Because the spine is different on this phone book. In one, it's the city, and inside is everything about that city. On this one, it's by zip code. And so same idea with global secondary indexes in DynamoDB. It's kind of a separate storage place, separate place where that data is held. OK, so that's a good way to understand how Dynamo works for retrievals, partition key, sort key, LSI, GSI kind of stuff. What about updates? When it's time to change one of these entries. You do those in the base table. You want it in the LSI. You want it in the GSI. But for simplicity, it's nicest if you just update it in one place, just update it in the base table and let the propagation happen to the other two. Since you're kind of an expert crowd, you know that the LSI propagates immediately, right? It's one of its advantages because it's in the same book. The GSI propagates eventually, quickly, but eventually, because it's in a different book, right? So the LSI same, GSI separate, and you update as the arrow shows. It propagates with a little stream. Typically, you know, a millisecond is kind of the typical, but for various reasons, it could be longer. All right, now that's how books work. Let's think about how we store the books. Let's picture that we're in a library, and we're going to go to the library to look up all of these phone books. If I put all my books in one library, I have an issue. Audio is really questionable, isn't it? Mm-hmm. If you have anything you can do about audio, let me know. I'm happy to hold something or whatnot. But if there's a fire, we're going to lose all our phone numbers. We don't want that. If there's road construction, maybe we won't lose it, but we won't be able to go and access it. So what we should do probably is we should keep multiple copies. Let's have 3 libraries, different zones of availability, one might call them, across 3 physically separated libraries. All right? So now we're going to have 3 libraries, and I can go to any one of them to access my phone numbers. We're going to have to do an update. We have 3 copies. How do we handle that? We'll elect a leader copy of each book. We won't do a leader library, because then all the rights would have to go to one library. We'll just do each book will elect its own leader across the libraries. The updates for that book need to go to that location. OK, now we need to actually put books on shelves in a physical world, right? When Dynamo does this kind of lookup, there has to be a physicality on the back end. So we're going to call these things shelves, or one might call them partitions. And in a library, we're going to have different organizations. So like the west wing will be all the city organization, and the east wing will be by zip code. Because remember, those are different books. And so we're going to have over here is one kind, over here is another kind. Each shelf is only going to be so big, so we're going to have to pick some number of shelves to start with. And we'll start by default with 4, let's say, which if you created an on-demand table in Dynamo is the default you're going to get as well.
And we say 4, and in addition, there are 4 shelves on this bookshelf, so keep an eye on them as they change and split. This was an Adobe Illustrator graphic, and I'm very proud of it. And so as time goes on, it'll split, and you'll see some changes. Yeah.
Have you seen Sean's Adobe Illustrator? All right, and I think this part's really interesting. How would I place the books onto these shelves? Because I have these cities, and I have to make it easy to find them. And I think the natural thing you're going to do is alphabetically, right? That San Jose should be under the S area, and Santa Clara should be under the S area, and San Francisco should be under the S area, and San Mateo should be under the S. Uh-oh. I think I figured out our problem. It's not, this is a lumpy organization if we do it alphabetically. What else could we do? We would like it to be smooth no matter what the partition key topology is. Here's what you do. If you can still hear me with this sound. What you do is you hash the names. And you store based on the hash. And because any variance in the input dramatically changes the output, you're going to get very nice even distribution on the hashes. And so now with 4 shelves, you're going to have very close to even distribution across the 4, even if your partition keys are very similar. And we'll have the librarian do that for us. And that's why we will call the city the partition key or the hash key, depending on where you look, right? In the UI, it's a partition key, and CloudFormation, it's a hash key.
Yep.
Now, each shelf is only so big. So at some point, a shelf is going to get full. If we keep adding more people, adding more cities, what do? The easiest thing to do is just split somewhere. Nice Adobe Illustrator expansion.
Thank you.
Yeah, it's very good. And so you'll pick a point, generally in the middle if it's expanding because of a size limit, where it says, I need more room. And just think of a physical library. I'm just going to move my books to 2 shelves, splitting at the midpoint. And now I've got plenty of room to grow. And notice how the ranges have adjusted. The key space of Dynamo has done this. And so this is what Dynamo does when a partition gets real big. What if a city or like a zip code gets bigger than a shelf? Well, New York and whatnot are very big cities. They did this already. They just make multiple books for that city, alphabetically by the sort key, by the last name. And so you do the same thing. You can split across the shelves the same city, but in just different books. And it will pick a sort key that's a good split point for you. And in fact, if we think about the physical world, each shelf only has so much space for patrons to visit. If people are coming to read or write to that shelf, at some point it'll get a little bit heated and maybe too much traffic. So what do? We call Sean and say, could you make the Illustrator graphic expand again?
Yes.
Yes, he can. And we split across shelves again. In this case, not splitting because of size, but splitting because of the throughput that each shelf can support. And you want more throughput. And this expands it greatly. And you can split down to an individual item. One phone book that is just this name is how small Dynamo can split things out. So you can get the maximum per partition read and write capacity to an individual item if you need to. It will split like that for you. This actually makes, by the way, performance testing Dynamo a bit tricky, because what you try the first minute is not the performance you're going to get after 10 minutes, because it's going to expand. It's kind of like testing how strong your bicep is by everyday testing, and you're like, my results are terrible. The number keeps going up. Yeah, exactly, because you keep working it out. So if you work out your database gets bigger, stronger, better. So in review, think of those shelves like the DynamoDB partitions, replicated across 3 availability zones. And every table, when you're designing, gets a partition key and an optional sort key. The sort key is not required. You could just have it be like this city is this number. But in our phone book analogy, we're using a sort key. And you have an LSI, which is kind of like the yellow pages, and a GSI, which is like a whole other wing of the library with a different lookup key. And the writes always go to the base table, and they propagate to the indexes. Tables start with the number of partitions needed for your needs. If you're in provision mode and you say you want 10,000 writes, we'll give you at least 10 partitions, because that's what's needed to support that level of write. Nowadays, we actually announced warm throughput. If you know about that, this is really cool stuff. You can direct an on-demand table to say how big you need it to be, the read-write rate you want when you create it. And so it'll be born with extra capacity based on your needs. And that's kind of like saying how many shelves you want in your library. And partitions have a desired size. They don't like to get too big. They want to be small enough to be able to move between nodes without you ever noticing, should we want. So, try to keep it around the 10 gig and not get much bigger than that. And there is a limit. 3,000 read units, 1,000 write units on a partition is the limit today. And so with reads, each read unit is 4 KB. Eventually consistent is half that. So you could do 6,000 4 KB eventually consistent reads to a shelf. And 1,000 writes. Each write is a 1 KB chunk. So you could do 1,000 1 KB updates to your phone books. And partitions do split when needed for either the size or the throughput needs. And so think about the partition key, because a lot of what Sean's going to do next is about partition keys, right? He's like, yep. He's not just an Illustrator guy. So the partition key helps you assign to a partition, but it's not a singular assignment. Right, that same PK might be split across different places, like where New York is on different shelves. And also, several partition keys will naturally coexist on the same partition. That's how these shelves start, where a shelf is pretty long and has a lot of cities on it. Okay? And so that is, hopefully for those of you who've done a lot of DynamoDB stuff, that was fun. And if not, hopefully now you're up to speed and ready for Sean's core data modeling concepts.
Yeah, exciting. Hi, everyone. I reintroduced myself. I don't think you know my name by this point. So I've been at DynamoSA for a long time. I'm based in Dallas, and I'm super excited to come and talk about the core data modeling concepts for DynamoDB. OK, so I have the bulk of this presentation. I'm kind of excited, but Jason, you can interrupt at any time, whenever you like, and then hopefully we have some time for questions at the end from everyone out there. And we'll probably have to take them, though, from the base of the stage before they kick us out. So talking about PKs and SKs, it's well known that PK is partition key at this point of the presentation, and SK are sort keys. I want to clarify though, if you make a table with a partition key and a sort key, you need to always include a sort key on the item. And when you put those two together, a given PK and SK, those are the row selectors uniquely identifying the row. So if you're brand new to Dynamo, never looked at DynamoDB table in the eye, you need to know those two things, put them together, and then you uniquely identify the row in DynamoDB. So in crafting this presentation, we had this idea that we would tell you about PKs and SKs, what are some good values for them. And my approach was to be very literal. It's just like, hey, here's all the options, like PK is limited to 2,048 bytes, sort keys to 1,024 bytes. But Jason kind of corralled me back and pointed to, well, we should probably be given some opinions, some more prescriptive guidance. And so we're going to talk about some facts about partition keys based on some of these boundaries and sort keys as well. So traditionally, when we model data in DynamoDB, we're going to go with a string data type for our partition keys and sort keys. This is what we're going to recommend because with those, you include entity information, which is things like a noun. It could be a person, a group, a role. You can include those in the prefix of the key. So we're going to recommend that you go with that. Also, when you're choosing the values for your PKs and SKs, you could go with the UID, but it would be much better if you could have something like a unique identifier associated with a label. So we like decorated names like cust ID, which tells you that, in this case, 123 is a customer ID. When you're looking in the management console, you want to know exactly what you're seeing. When you're coming up with the names of these attributes, this is called the key schema in DynamoDB. We're going to recommend that you go with just PK and SK, and that will lock it in across the whole table. And that's one of the things that you can't change after the table is made. Those are the attribute names that define the primary keys of your Dynamo table. It also is going to allow you to save on bytes, which is part of this presentation where we're going to cover how to get the most out of every write unit, make your items as small as possible by having short attribute names. And as I mentioned, you can't change these. If you wanted to, this often will require an export to the DynamoDB table and a re-import. It's important to get those names right at the front. All right, let's talk about some sample different partition keys. We're introducing terminology that you can use and hopefully kind of take back in conversations when you get back into the office. First, we're going to talk about the primary key, the partition key that's more descriptive. And so the entity type is labeled. We're going to prefix the PK with that type, and then we're going to know that like 89109 is a zip code, and not something like the door code to the back of the MGM Grand. And this is the most traditional way, by the way, that we construct our PKs. You can also include shards at the end of your PKs. And so a common design pattern is what we just call right sharding. It can happen on the primary key for your base table or for your global secondary index. We're going to do this by suffixing the key with a number from a set range, and then we're going to choose that on write. So we're going to say it's going to be 0, 1, or 2. We can do that randomly choosing a number between 0 and n, or we could go with a calculated suffix. To learn more about that, check out our documentation, which talks about calculated suffixes and how to choose a good key. So we could also go with the multi-value key. So PKs can often be used to build collections. So we're collecting related data together and storing it. In this case, we can store information about the MGM Grand properties under this zip code. And note that if we want to update property in Dynamo, we're going to need to know the full PK value. So we're going to need to know that a property is owned by MGM and an 89109 if we want to update that row. Because in Dynamo, we require an equality statement on the partition key whenever you're querying it. And of course, when you're updating it, you need to know what the PK value is. Now, let's talk about sort keys and what those can look like. Once you identify your PK, you get to this point, and items under a PK will need a unique sort key or SK to identify them. I want to make sure that's emphasized. So often in our sort keys, we include the type information. And we call them sort because data is sorted by disk in DynamoDB. If you look at the API, it's called actually a range key. And I think sort key is probably a better name for it. And when you include the typed SK, we can include the attribute type as a prefix. And then this lets us do a query saying, give me where the partition key is equal to like zip 89109. And this sort key, SK, begins with name HUN. And I'll find probably Jason Hunter's information, unless you've, I don't know, are you in the white pages? I don't know.
I haven't looked in 20 years.
Yeah, it's been a long time.
What's nice is if you have different sort keys with name, but some other attributes too, then you can pull all the names in the zip code, but all something else in that zip code and have them co-live together under the same partition key. So you're kind of pre-grouping them to these are my names and these are my something else.
Yeah. Yeah, you're creating a collection of information, and it doesn't all have to be people. It could be businesses, it could be properties. Sort keys. A most common sort key value that I personally see is something like a timestamp. So it could be like this, which is the epoch value, the number of seconds since Jan 1, 1970. And that would be a timestamp. And this is great for sorting data by disk. So I can say, give me data between 2 weeks ago and 1 week ago, and Dynamo can retrieve that out of a partition from the service. Another way that you can construct your sort keys is you can create them hierarchically. And so often we need to store this related data together, and we have something that we know, which is like a geography. So there's United States, then there's a state, and then there's a metro area. And so you can write the, let's say, inventory information under a key like this, under Las Vegas, Nevada. And then you can store the same data as well under a less specific key, such as USA, Nevada, creating an aggregation on the state level. The hard part, though, is maintaining those and keeping those up to date and making sure that the data is copied over. So
this is like 3 values in one, because I can say, give me everything from the USA, everything from Nevada, everything from Las Vegas, all out of the same sort key.
Yep. Yep. Okay, now let's step through a NoSQL data model. Hopefully this was clear. This is kind of what we're building to. It's a core part of this presentation. We're going to employ everyone in this room. You're hopefully be able to put yourselves in the shoes of, we'll call it Example Corp. And so your job is to think about building a database schema for a chat service. This could be something like a ChatGPT. So you want to design a data model. It has conversations and threads. Each chat has information like the temperature, the max tokens, the model that's being used, and the version. So we want to, of course, have the promise of the scalability, being able to go to any level of throughput, as well as the low latency. And if you need those two things, DynamoDB is a service. Here are some of the requirements. We want all the data to be stored based on the user. So a user can have multiple threads. I may start a conversation on my mobile device, put the phone in my pocket, open up my laptop, and want to view the most recent threads. And all these threads will have the metadata, like some of the information I mentioned earlier. Perhaps we want to know, what the original system prompt was. And because this is AWS, we want to make sure we scale. Yeah, we want to plan for scale from the start, especially if you're involved in a startup. You want to aim for the top level. Now, that being said, we need to really get this product out the door, so we're going to start with the most basic design and iterate from there. And later on, we'll encounter some problems and then suggest to you a couple solutions for those. So initially, we want to store data under the user ID. We're going to make that the PK. Now, the sort key should have a date, and that would be something like year, month, day, which is the ISO 8601 format. And it just goes from the least specific to the most specific information. It's going to give us a natural sort key, so we can find threads by creation date for every user. Now, every thread will also have a unique thread ID, because we expect that you'll have multiple chats inside the same day. Now, to start, we are going to split out the metadata to its own item, and that's going to be the system prompt, like I mentioned earlier, the model type, and then settings such as temperature, max tokens, top K, top P. Now, for each message in the thread conversation, we're going to be creating a new row, and it's going to have a user's message and a copy of the response. So in review, we know it's easy to get the latest threads because they're sorted by that create date. However, if we only know the user, however, if we want to find something by thread ID, it's actually quite complex because we've embedded it inside there. Perhaps you can think how we could query data out and find information by thread ID. We might use a global secondary index. So we don't have, in the end, we don't have a straightforward way to get the data out. We can get the metadata, and we're actually going to talk about maybe some ways that we can get the metadata back in Dynamo. So let's look at how we modeled in NoSQL work for DynamoDB. A little small, I'll talk you through it though. So here's our PK. It's going to be user with a user number like 1, 2, 3, 4, 5, 6. And the PK is descriptive. It includes the entity type. At the very bottom, you can find that metadata row that I was mentioning. We break out that data that doesn't change very much, but it's just kind of common for the whole conversation. In fact, it does, one element of it does change quite a bit. We'll get there. And then the other type of data is every time there's a message in that thread, in the conversation, it appears as a separate item. So one potential weakness is that there's potentially some large form responses that can be made, and you can paste in a ton of text. And so we need to think about how large and how large should the item be in DynamoDB. One option is you could compress it. So if someone has a lot of information coming in, you can run it through like gzip and then store it as a binary data type. Or potentially you could put that data in S3 and then put an S3 URI in the DynamoDB item. Right now, though, we're just getting started with this design. We want to make sure we kind of get it out the door.
So, some interesting things versus like a relational is how we did that user hash. That's because later on, maybe we want something else in this table where the partition key isn't just a user. And so now we can tell that that's a user ID, but also later on, if we wanted to put something else in this table, we could with a different prefix. And it's fairly common to reuse your tables that way. And we did a T hash in the sort key because these are our threads, but maybe also for this user, we're going to want to do something else, their address or their preferences, and we can put it in the same table under the same partition key. Why would I ever do that, Sean? Why would I put like different things for the same partition about you in the same table instead of having many tables?
Well, it's going to lower our round trip time. If I need to get all the information about my user, I can do one query without any sort key condition, and then it'll get me all the data back. Another thing is that for access control, if I wanted the mobile client for some reason to talk directly to Dynamo, I could give them access to user 1, 2, 3, 4, 5, and then make it read-only. And now with their temporary credentials, they can retrieve information directly from the service of DynamoDB. And it may not be the primary path, but it'd be a good backup option to retrieve data.
Yeah, so we're doing some designs here that are future-proofing us. PKSK, since we don't know in the future if we're going to keep using user ID as the partition key. You can call it user ID, and a lot of people do. But if you call it PK, you've given yourself an out in the future. And SK2, we aren't calling it thread or anything. It's like, maybe in the future I want it to do something else. And then after that, you'll also notice that the attributes aren't the same across each item. That's okay. Every item is its own schema. So the meta down there has a model, while the other ones are intent at that point, and that's just fine.
Yep.
It's not relational anymore.
So we have this use case where we want to get just the thread metadata, and that's the metadata item. And the idea is that whenever we add a new message, we're updating a timestamp, which would be the update date time. The common thing is I need the most recent chats that I have. So how can we get that information back? Well, if we index the timestamp under a GSI, using the user ID as the partition key, and the sort key would include the timestamp, including the T hash, the T pound sign. We should probably say pound sign because we're talking about phone books and phone numbers. But that's going to distinguish it for any other data for that user that might be in the GSI. And then we can say, give me these items with a limit of 10.
Why did you do a GSI if the partition key is the same?
Sorry, what was the question?
Why did you do a GSI if the partition key is the same? I thought LSIs were when the partition key was the same.
Yeah, the benefits of having a GSI is that you're decoupling the consumption of capacity from the base table. So if you have a lot of writes going to a Dynamo table where you need an alternate sort key, if you go with the LSI option, you take your maximum throughput and you cut it in half. or potentially even greater, because you're having to consume capacity to update the local entry. So for example, with the Dynamo table on a single partition key, you could normally write at 1,000 writes a second, 1,000 1 kilobyte changes. You'd be limited to just 500 with an LSI, but then if you were modifying the entry in the LSI, you'd be limited to 333 repeating units for write, because you have to delete the old entry and insert the new one. The point being that with LSIs, you have these limitations, and so we prefer going with GSIs, but we understand that there'll be a compromise. And so if you look at this design, we can come up with this GSI. The one thing to note about them, though, is that they're eventually consistent. So there's going to be some delay before the writes eventually make it to the GSI. We know that's on the order of milliseconds or tens of milliseconds.
I like your index name, GSI1PK, GSI1SK.
Yep, yeah, very common in our designs. We'll go with GSI1 just because this is the first GSI, and then we'll put PK and SK in the name. There are certainly cases where you want to make something very custom, but generally we want to make a GSI that we can overload, which is what this strategy is called, index overloading. Yeah. So talking about the GSIs, what are some of the other options that we could have gone with and the trade-offs? I think there's a lot of value in thinking about this. Why did we go down this route, and how else could you have solved this problem to get the most up-to-date view of a user's threads to figure out where they should pick up? Now, first of all, you could just say eventual consistency is good enough for me, because GSIs can be tens of milliseconds behind. And how often do clients swap devices, like I mentioned earlier, going from a mobile device to a web client? Now, the LSI conversation.
We lost your sound.
Talked about, okay, that's weird. The LSIs, we talked about those already. They do have their downsides. And one of the things that was mentioned earlier about LSIs is that there's this kind of, there's a limit to them. And so often customers hear about the 10 gigabyte partition limit and they think it applies to LSIs. If I can get in my soapbox for a minute, LSI collection limits are what is limited to 10 gigabytes. So if you have the same partition key but different sort key, so for example, if it was user ID, the sort key was your thread metadata timestamp, your create update time, or your update time, that whole collection for a given user is limited to 10 gigabytes. In addition, LSIs do change a little bit about how the table works underneath the surface, and you're welcome to ask about that later if we have some time. But in general, our customers will have to go with GSIs if they've already created their Dynamo table. You can't add an LSI after it's already launched. Now, what surprisingly a lot of customers do when they need to have these kinds of indexes, if they don't want to do LSIs or GSIs, they'll actually just do 2 writes, and they'll block until the write completes. So they'll do a put item, and wait. And as soon as they receive the response that the writes were durably written from Dynamo, they'll return the operation upstream to say, like, yes, success, we wrote the data. Now, there's an easier way to do that using our transactions API, and that's a little more interesting. So you could use a transact write items call with our transaction write API. It's also known as ACID transactions. You can change up to 100 items at a time. All the operations will complete or fail. And you also have item potency, where you can provide a client request token to us, and then we'll make sure that you cannot repeat that operation within a 10-minute window. So if you go with the transaction writes, you're going to pay twice, and that's the downside. So instead of paying 1 write unit, it's going to be 2, once for each phase. So it's a little more expensive, but you're going to have the read after write consistency and the peace of mind. Actually, I think most of my customers would consider using 4, the option 4 with the transaction writes, and they're not even using the transact get items call. I don't know if you've seen that, Jason. Yeah.
I mean, it's simple because it updates transactionally, but you do pay a 2x because it's a transaction versus double writes. So 3 is half the cost of 4, but 4 is simpler.
And I think a lot of times customers are calling Dynamo through Lambda functions, and it's possible that the batch could fail, and Lambda would reprocess that, and that Lambda function would be called again. But with the transact APIs, with the client request token, there's item potency, so we'll make sure that the operation only runs 1 time. So really helps a lot with the development effort. Okay, so let's say we've thought through what are the trade-offs, we've gotten the product out the door, but then we start to hit some scaling problems. Maybe someone starts looking at the bill. Maybe we want to make money and we need to turn on metering. What are some extra things that you can do to enable these extra things, like shrinking our item size, getting the most out of every capacity unit, and then also doing counting, which is can be kind of hard in DynamoDB, but thankfully there's a blog that we're going to talk about. One of the most interesting things is about Dynamo, if you can get the item, let's say 33% smaller, you could potentially cut your costs by 33%. And who wouldn't want to spend less on DynamoDB? So when you have data that's infrequently changed, we have situations where customers won't necessarily be aware of this, but if you just make a change to an item, you have to pay to rewrite the whole item. So if it's like an 8K item, you make 1 byte of change, it's 8 write units to update it. I had a retail customer, not Amazon, but they had 80,000 products in their catalog, and each day they had 800,000, so 10x the number of changes. They're mainly changing pricing information, so it's interesting. So if they were to shrink their item size down from 16K down to, let's say, 10K, we have a significant reduction in cost just on the write units. And so what we're going to do is look at our metadata attribute. So if we take our model version, we run it through compression, we can maybe simulate. We can try gzip, we can try LZ4, and see what final item size can we get to. And so in this example, let's say we got to 5.1 kilobytes. That's a pretty good size, but that's still going to be 6 WCUs, but it's pretty good. Now note that compression, if you make any changes like this, it's all going to be on the client side. So you're not necessarily going to find a client from AWS to assist you with this. And when you store the data, you're going to be putting it in as a binary data type, and it's essentially going to be a base64 encoded object. So take whatever the representation is in your code, compress it, base64 it, store it in a binary data type in DynamoDB. Furthering this design, as we try to cut down on the number of write units, considering what I mentioned earlier, how one small change has an impact where you have to rewrite the whole item, potentially we could split out the static and the dynamic data. So we have this thing where every time you put a message in, you're updating the date time. If you put that into a separate item, now you can spend 6 write units approximately to update the metadata when you need to do it, it's infrequent, but only 1 write unit to update the static, dynamic information. And with this way, you can save quite a lot on write capacity units.
Yeah, the main thing there is people, I think if I change a number, then, well, that's less than 1 KB, therefore I pay 1 write unit. But if it's a big item, if it's a 100 KB item and you change a number, that's 100 write units. Because it's, or deleting an item, it's the size of the before size. If you update, it's the bigger of the before after. And so, let's not do that. Let's move that dynamic thing that we change a lot out, only pay 1 write unit for it instead of many write units. And that alone saves people really heavily. This has become a cost optimization talk, but data modeling is about advanced cost optimization, I think.
Mm-hmm. Yep. So there's a lot of laws that say people have the right to be forgotten, and I know that when I delete a thread, I want the peace of mind that it's deleted. And so often, if I have an account that's been around for years, there will be megabytes, tens of megabytes of data in a database. However, I want the certainty that I can do 1 write, make 1 change, 1 API call, and ensure that my data will eventually be deleted. And so we have this new requirement that users need to be able to delete their threads, but this might be an extended amount of information, especially as time goes on. So one way that we could go about this is using a soft delete. And so instead of deleting the item, we just set an attribute. And that could be on a thread or it could be on a user. Now, this becomes a bit of a problem. We need to find this needle in the haystack. So we have the design that we mentioned earlier and showed you, and now we need to find a single attribute that's been set. And of course, I want to have some ability to scale this system. How can we extract a view of that? And the answer would be a global secondary index.
This is the sweeper thread that runs periodically to find deleted threads and get rid of them for real.
Yep.
So you don't want to scan the whole table to do that.
Mm-hmm. So we can create this GSI. We can have it scan the Dynamo table, or we could have it query it. And I think query is much more efficient with the GSI, especially because we're probably going to use an overloaded index. GSI2, we're making this, and it's, the status of deleted.
So on an item, you would mark it s# deleted on a GSI2PK to mark it as self-deleted. And then that'll make it pop up in the sparse GSI, so I can immediately know all the deleted thread IDs to go to really delete them.
It's like raising a flag or like a sentinel value. It shows up, it appears over to this index, and then now you know that it needs to be deleted. But there's a scalability problem. Some may know. Okay, still hear me.
What if I need to delete many per second, Sean?
Thank you for covering.
Yeah.
It's a great question. Well, I think what we could do is do right sharding. So if you do right sharding, you're choosing a value from a set range, you're suffixing it to your partition key, and in this case, we could do thread state, and we could mark it as deleted, and then include 0, 1, and 2. And so what we're trying to overcome is that GSIs, when you choose those primary keys, they are effectively DynamoDB tables underneath the surface. So you see an index name, but we see a table ID. We see partitions, and you don't see those. You don't know about those. There's CloudWatch metrics for GSIs. So picking a highly unique key is very important. So if you went with the last design, you'd have potentially millions of rows that could be updated and marked as deleted. And then they would all funnel down to the one partition on a GSI of deleted. And with this case, if we go with the shards, now we can have, in this case, 10 different shards. And so instead of creating this funnel down to one area, we spread out the writes and overcome some potential bottlenecks that we could have.
So like in the phone books, if you wanted to track dead people, you would have the book of the dead. But if you only had the partition key, which was like the book of the dead, you could only have 1,000 deaths per second.
Yeah.
Right? And if you wanted 10,000 per second, then you would have 10.
Yep. Yeah. Exactly. Okay, so
he's like,
moving on. All right. Okay, what are some other ways that we can go about this? So a lot of times when we create our design, we think, okay, our only desired state is deleted, but maybe we want to archive them. We want to go to a softer version of it, even softer version of a delete. And so we really like giving you options. So here is another way that you can construct this. And so we're not saying prescriptively this is how you should design the service, but we're giving you options. So here what you could do is you could go with, instead of putting the thread state in the PK of the GSI, you could put it in the SK. And so now you just have S0, S1, you pick those values. Now, now's a great time to actually talk about calculated suffixes, which is a bit of a weird problem to talk about, I guess, if I don't have like a little graph showing you how it works. But the idea with calculated suffixes is that we're not going to randomly pick between a set range, because a lot of times I think when people hear random, they just think, oh, every time I update the item on the base table, I'm going to pick a new value for the GSI shard key. But that's not the case with calculated suffixes. The way you do those is you take something you know, such as a user ID, and then you come up with a hashing function. The hashing function that you make, which is in our documentation, we explain how to do it, it's always going to have the same deterministic output. So for user ID 1, they're probably always going to be on S0, for example, and then user ID 2 could be on S1. And so I just wanted to dispel concerns that as you modify your items on the base table, that you're going to be spamming your items across the different partitions on the GSI. You can have a set shard number based on what you know, and that's called a calculated suffix. So check out our documentation for that. This is still a 300-level presentation.
Are you doing that to avoid right amplification?
That's what we're trying. We're trying to avoid the right amplification issue, where if you update an item on the base table, and then you change the GSI shard, and you change it with each write, you'd be deleting an old entry and inserting a new one on the GSI. So we want that shard value that we choose for the GSI to be the same for each DynamoDB item.
Right. When you update it, if you change it, the GSI sees it as the delete and an insert, which is 2 writes. That's the amplification. And so if you can keep the GSI 3 PK the same, then you write the same item and you don't amplify it.
Yep.
That was 400 level.
Yeah. Yay. Always wanted a 400 level talk. Okay, and then just to be clear, in order to figure out all of these things, all these items that need to be deleted, all these threads, you're going to do a query, 10 different query calls, in fact, in parallel. Whichever is slowest is going to kind of slow down the whole operation. When you fill up a query response, maybe at that point you're like, oh, I need more shards. And then you just increase the maximum value. So 0 to 9, it's 0 to 20, whatever you need. And I have a blog on that, how to choose the right number of shards for your DynamoDB table.
Yeah, you see this sharding a lot because Dynamo does a lot out of the box. 1,000 writes is quite a lot, but if you're saying, but I want to be able to have a GSI that watches for a certain flag, in this case deleted or archived or anything, and that one's going to be more than 1,000 a second, what do I do? Well, just have more than one partition key. So we'll have n many. And you can read his blog and pick n, but make n big enough. Mm-hmm. And if you wanted to do 100,000 a second, no problem. You have 100 shards. Yep. At the expense that when it's time to read, you do have to look in 100 places. But for this use case, I'll read one, delete. I'll read the next one, delete. It's a background worker. It works great. And there's really not a limit in how big you can go. If you picked like a relational database with an index, that'll just become a bottleneck without the ability to do a shard oftentimes.
So what's a really hard problem with any database? I would argue it's counting and counting accurately. So I'm going to show you a technique to do counting and then to also make sure that you're deduplicating those counts as you go along to make sure you're not double counting. Anyways, I think it's kind of a novel way to do it in a DynamoDB table. Not a lot of people know about it. I sat with Jason in preparation for this, and it sounded like it was a new idea to you, so hopefully it's new to everyone here in the audience. So here's the requirement. We need to be able to count usage because it's time to make money. So how can we be sure that we're billing for every interaction? So we can track it in the metadata item, but I'd rather do it asynchronously, hooking into the DynamoDB stream. DynamoDB streams is our change data capture service, which provides changes of your DynamoDB table for up to 24 hours. Now, we want to try to do this counting pretty quick because perhaps we want to use the same data to prevent abuse, because sometimes people will send like tens or hundreds of operations in a second to try to get past some of these filters. So as fast as we can get this through, that'd be best. But perhaps if you have that requirement, you want to consider some kind of upstream TPS limits, find another way to kind of rate limit whoever's calling your API so that it's not all dependent on the database. So here's how it would look. We'd have a change. I'd insert a message to the thread, and I need to make sure that, let's say, I can only make 5,000 of these on my, let's say, a corporate account in a day. And so whenever you make a change on a DynamoDB table, it's not when you do a put, it's not when you do a delete, but when you actually modify the data, the operation has an effect, such as changing a timestamp. It gets put in the DynamoDB stream. Then you can attach a Lambda function to that. If you don't know, Lambda has filters, which are great. You can say, only invoke my Lambda function if we use this model. So if you see like Claude in the sort key, it can make it appear and then go invoke the Lambda function, which is what I'm trying to say. And so you can just do kind of a count. And so if you do an increment, you do atomic operation, you can have a rough way to track operations. But it kind of has limitations. So let's talk about how we can have better accuracy. So in Dynamo, on the API, and when you're doing these write operations, you can consider including message ID in a string set. So Dynamo has this idea of string sets. It's a data type, and it's a set of strings, and you can only have one unique value for any given string in the string set. And so if you do a write operation, you can say, conditionally, add the string to the message ID's string set, so long as it does not contain the string set. And so for small counting, if you're trying to make sure that you only process the message hundreds, potentially thousands of times, especially if your message IDs are very short, you can ensure that you're shrinking it down. And you want to keep the items as small as you can, really, at the end of the day. As you add message IDs to this design, you start appending them to the string set, the item will get large, but we want to try to avoid that. So this is a unique kind of novel idea. And so you use the conditional update to add it, that's the key word, to the string set, and with the condition that it does not contain. It's not contained in the string set. So anyways, I thought that was pretty interesting. And then we also have this blog written by Jason. A.co/DynamoDB counters.
The challenge with these with counting in Dynamo is it doesn't want to do a big count for you. It wants to be fast. And so the idea is pre-count, right? Keep a count, and then when it's how many times did this happen, you just go ask. But that means we have to keep that counter, which means we have to watch the mutations, have triggers fire, and keep a count updated, which works pretty well until you realize that lambdas can be invoked again if for any reason the lambda crashes. And that's where this gets in, where he's keeping track of what's recently happened with that message ID so that if you have the lambda double invoked, you're not going to double count. Depends on how accurate your counters have to be, but this blog was, I think, an exploration of 7 ways to maintain accurate counters when you need increasing accuracy.
Yep. There's other ways you could do this. You could use Elasticache. You could pick your engine, like you could use Elasticache Valkey, and you could track it in memory. It's one way to do it. And so, yeah, we're just showing you how you might do it in Dynamo because we're Dynamo Solutions architects, and we tend to be a little biased towards that database. So. But we're gonna show you that we do think about other services here at AWS, and we like to include them. And we're going to talk about a new search requirement. So one thing that Jason and I discovered, we were talking about how a lot of client-side searches work. Like, let's say I'm trying to find, where I mentioned what's something that's not Lambda or Dynamo. Pick an AWS service. Reinvent. Okay, sure. I want to get help. Search that chat I had about my reInvent talk and how to get 5 stars on your rating. But I'm like, oh, I forgot what it was. And so a lot of these searches, what they do is they're client side. They're not going out to like Elasticsearch or OpenSearch. Instead, they're pulling down the metadata and then you're searching locally. And this comes up a lot where customers have the need to search with alternate patterns. And so with Dynamo, you could always add a global secondary index. But one thing that you could do or try is integrating with OpenSearch. So DynamoDB has the zero-ETL integration with the OpenSearch service. So if I needed to search for all the chats that I've had, I can put them into an index. Now, I'm not an OpenSearch expert, but I do know that this gets your data from your DynamoDB table into Amazon OpenSearch service. It uses a plugin for the OpenSearch ingestion service. You can do many Dynamo tables to many indexes. You can do just 1-to-1. You can do one DynamoDB table to many indexes. The options are limited, but very expansive. You have full access to data prepper. So if you know about that, you can combine attributes together, or even split them apart. So if you're using DynamoDB's single table design strategies, and you have 2 values concatenated together, you have the option to modify them with data prepper. And then it uses a full export to begin. And so this is going to allow you to hydrate the index, and it's fully managed for you using the export to S3 service that we already offer. And then from there, it uses CDC, DynamoDB streams, to queue up the changes and send them over to the index.
Yeah, we announced this last year, and it's much simpler to do the integration now because you're not writing the Lambda code that copies it. You just push a deploy button. You have a YAML that defines how you want it to be reshaped. And it's very powerful because it uses that data prepper.
Yep.
And now you can do searches against your Dynamo.
Yep. Don't you have a workshop that uses this integration?
Yes. I should have plugged it.
When is it?
Tomorrow at 11:30.
What's the code?
I don't remember. DAT305. I do remember.
DAT305. Yep, that's right.
I do remember.
Yeah, it's good. It's good. It's based on our Bedrock workshop.
Yeah,
so.
we'll use this.
Yeah.
We'll hook you up.
And then we have DAT421, which is our builder sessions, and we also use the zero-ETL integration. So.
Cool. Hey, it's my slide again.
Yeah, it is.
All right, this one is kind of unrelated to data modeling, but I wanted to really spread the word on this because it's a way to save you a lot of money, and I want to get you your money's worth from this talk, shall we say. And so if you know about PITR, which is point-in-time recovery for Dynamo, the idea is that you turn this on and it keeps a change log of all of your changes, and if something goes wrong, if you delete an item accidentally, overwrite an item accidentally, any sort of application level corruption, you can undo the damage because you've got that log. And the classic way that you would always do this is you would do a restore before the damage. And then you'd be able to have a copy of the table before it was corrupted. And then, well, you probably had some real good writes, and then you'll figure out how to merge the two together to end up with the final version.
Yeah.
And so is there anything wrong with that?
I mean, it's purely like cost to export the data as well as the amount of data that you have to go through.
Yeah.
If we're talking data and I have like 4 hours to get my service back up, that's a lot of queries to do to find just the data that changed.
Right, the bigger your table, the more the cost because a restore is based per gigabyte. So here's what I want to just spread around, spread this to people because it's a great way to save money. We added incremental export not too long ago. With this, if you have PITR enabled, you can say, show me the changes that happened during this time window. It'll give you the before and the after view of how the item changed during that time window. You can go down to 15 minutes, as big as a day. And you can therefore, if you know that you did damage during a certain time period, say, not restore the table before, paying per gigabyte on the table, but you can say, show me the changes that happened during the hour of problem, paying by the gigabyte of log that gets processed, which is tiny, tiny, tiny. So what am I going to save if it's a terabyte? Well, a restore recovery at 15 cents per gigabyte is $150, and it might take hours to restore the terabyte. On an export, it'll be, say, a gigabyte of changes and cost you 10 cents.
Is this a replacement for like DynamoDB streams where you get a set of every change from the table? Or is this a replacement for the Kinesis data streams integration with Dynamo where all the changes from your DynamoDB table go into Kinesis data stream and then those can go into S3? Like, do they all produce the same results?
Basically, yes. So streams will be real time and you can apply it as you go. So the zero ETL with OpenSearch does that. But if you wanted to do an equivalent zero ETL where you didn't mind it being a little bit more chunky, then you could just do this. And every 15 minutes, you get the latest update, you apply it to the downstream consumer. That one's not really much more cost savings. I do kind of like the fact that I don't have to have a live stream all the time. I can hit the button every day and do the next daily update. But for this use case, I think it makes PITR way more valuable. So if you didn't have PITR, maybe consider PITR because there is a per gigabyte monthly cost to PITR, but now the recovery, if you had to 10 terabytes, 100 terabytes, when your tables get bigger, it's linear with table size. Now it's no longer linear with table size to undo the damage. So every talk I'm putting this in at the end because it's a great money saver. All right, we have 3 minutes for questions. And please do fill out the survey.